Good morning, everyone, and welcome to the 12th Finest Center's Research and Innovation Seminar. Today we're hosting with Dr. Kalle Toiskallio. I'm Matti Hämäläinen, and Stereo Voice. Yes, we have rehearsed this several times. Today's theme will be designing traffic systems with autonomous vehicle, modeling a zone, attitudes of people, and technical and legal reality.
Yeah, and this is actually first time we have this kind of setting. Previously we had, in our 11 session history, we presented something. Now we're presenting also, but there's a special sort of setting. If we think in publicity and sort of research publicity, there's a big weight that autonomous vehicles and autonomous traffic will happen quite soon. You know, behind the corner they will come, and then we just sit in a car without a driver, and it drives us somewhere and goes away, and life is easy. So that hasn't happened, as we all know, and yet. And well, my sort of insight is that the reason is that there are, even in that domain, there are very separate, very distant groups that doesn't talk to each other much. And today we have that kind of setting here. So we have the people who understand the traffic system, who are interested in traffic system and systemic change in urban traffic system. And then we have robotics people who are interested in vehicle, an autonomous vehicle and algorithms, how they work in their immediate sort of surroundings. And there's a huge gap between these things. And in this session, we try to encourage these guys to collaborate in the future.
And again, for now, this is a one-time exception. So instead of having the traditional research and innovation seminar where we have researchers and developers or practitioners, we hope that this will not be research seminar, so that we can keep the discussion in very pragmatic and practical level. Then again, if this format works out and if we have good discussion, then we will consider doing it in the future again. So bringing two perspectives from either the research world or from development of practitioner world, and trying to interfere those aspects with each other.
Yeah, and even if this time sort of research seminar, we have the same sort of pattern, that there are very short presentations from researchers, and then almost half of the whole session should be for discussion for you, the audience. Whatever you have in your mind, you can write it in the chat, or just raise your hand, or just start talking and asking, or whatever you have. You can share your screen if you need and want. Everything is allowed in this session.
So for the audience, especially new members, feel free to use the chat for any comments or questions directed at the speakers or at us, and we'll try to pick up relevant ones, and hopefully there will be even some discussion in the chat. Yeah. For now, let's get started.
Yeah. So first we have Dago Antov from TalTech, who's giving sort of general introduction for the whole thing. Then we have a bit sort of transport system perspective from Serio Agriesti and Udal. And then last but not least, Professor of Robotics, Raivo Sell from TalTech will give short introduction of technical and legal reality of autonomous vehicles, and level 4, not level 5 or anything else. And then we will discuss about the presentations and ideas and possibilities to collaborate in the future. All right, Dago, please.
Okay, thank you. Tere hommikust, hyvää huomenta, buongiorno, good morning for everybody. I don't know how many more languages we need today, but let's keep it more or less on those ones actually. Okay, I'm trying to share my slides. I hope it works. Yes.
Yes.
Okay.
Yes.
Thank you. My name is Dago Antov. I'm working at Tallinn University of Technology, or TalTech, and I was actually involved a little bit for this Finnish Twins project, but on certain case. So my today's idea is just a little bit to share these first results, what we get during this study, what we actually held last year. So the topic will be where autonomous vehicles could have positive effects, actually where. And the first to start, I could share you quite interesting information, actually. This is one of the report of the Oslo study, which has been made already a couple of years ago, but there is also a cover page. If anybody is interested to get this, you can look at the internet. You can find it quite easily when Googling. But what was very interesting to me of this Oslo study was that the researchers actually who have been written this report, they find out that in a best case, these autonomous vehicles usage could reduce traffic up to 31%. But in a worst case, traffic volumes could double and it will result in a complete traffic breakdown. So actually the perspectives might be rather different in this case. So what was our assumptions actually here? So when we started the research, our assumptions were that autonomous vehicles can be part of the MaaS solution. Probably everybody knows what is a MaaS. It's a mobility as a service case, and especially in order to complement the public transport network and services. So if we're trying to evaluate the possible positive or negative effects of the use of the future autonomous vehicles, I would say that we could take or should take actually account some special characteristics of the present autonomous vehicles, which are, they have at the moment relatively low speed. The capacity is not a very big one, it's relatively small, but the autonomous vehicles actually could have a potential for flexible service schemes involving in a part of it. And the potential use, I would say it would be something like to cover public transport services, especially on some areas where the demand is relatively low and irregular. I think it could be mainly for local transportation. And that means that we should think about usage of autonomous vehicles as a part of the public transportation system within a few miles. So normally, very often we call it the last mile solution. It might be maybe 2 miles, but not very much more. It could be a feeder to the main public transportation system, to the bus or rail or tram or whatever. And especially the autonomous vehicle might have some potential when trying to service a local demand, for instance, schools or kindergartens or similar things. So this is theoretically what we can think about possible use of autonomous vehicles. But our question is now, are the residents ready for such services actually? So what they did actually, we completed a survey last year, and the survey was conducted in the scope of the Future Transport Ecosystem Management Solution project, which was funded by the Finnish Twin Smart City Center of Excellence. We made a survey among the residents of one municipal area, which is called Rai municipality. It's very close to the city of Tallinn, located in the southern part or to the south of the city of Tallinn. So they have very tight relations, especially regarding the mobility schemes. That means that very often the people are actually living in Rai area or Rai municipality, and they are traveling every time as a commuters to the city, having their jobs or schools, or I don't know, making their services or whatever. So our idea was just to conduct an online survey among the residents of the municipality, and because the local municipality was involved in this research as well, so we made actually a little bit wider scheme, not only focusing on the usage of autonomous vehicles, but getting a little bit larger picture about the mobility in this municipality as a whole. So this survey was conducted at the period in last of April till at the beginning of June last year, and we get responses from altogether 819 residents, which seems to me that as a results are quite reliable. So as I said, it was not only focusing on the autonomous vehicles, but we actually shared the questions in 4 different blocks, I would say, or parts. The first about the mobility means, second about the public attitudes towards the possible tram network development, because the municipality has such an idea. The first is just what do we focus today? It's public attitudes towards autonomous vehicles. And also we wanted to get some replies from the residents about the possible proposals for the development of mobility services at the municipality. So let's take a few results of the survey. This is today's picture about a modal share in Raivo municipality. We asked actually 2 different schemes about the so-called summer period and about winter period, and here is a mobility share. And I would say that today's mobility of these residents are very much car oriented. So we can see that at the summertime, the car share is something like 73%. At the winter time, even more, up to 81%. The public transport usages are small. Cycling is very much seasonal. I would say that, let's say 8% is not too bad in Estonian conditions, but 1% in the winter, it's really low. It's very rather small people who are actually cycling in the winter time, and walking is not so much taking as an important part of the mobility in this area. This is a total picture about the background. And reasons for the car preference, as you see, the car was very much preferred. The people's answers are replied here. First, it's shorter. Secondly, it fits better at the travel scheme of the resident. And third, it's more comfortable. You see that other reasons are more or much less actually illustrated here. More private, no other options. I like driving the car, safer, cheaper, environment friendly, of course, not at all. So it's basically about time saving. It's about fitting of the travel scheme of the persons and about the comfortableness. And this is quite right, actually. If we asked actually how many minutes you spend for your everyday commuting as a resident of the Raivo, I would say that this is quite illustrative, this result here. So we can see that most of the people are traveling and using time, which is less than 30 minutes, less than half an hour. But if we take an average time, the people who are using the public transport, they spend, especially, let's say, in the morning peak hour, something like 35 minutes if they use a bus. But if they drive a car, it's less than 20 minutes. So the difference is, for my point of view, rather essential. So that means at the moment, the most important reason of using the car instead of using the public transportation is a time. If you use a public transportation, it takes much more time for you than traveling your own car. That's one of the most important part. Now, let's focus on attitudes towards autonomous vehicles. We had actually more questions in our survey, not only those ones here. We also asked people, what do you know about autonomous vehicles? Have you seen them? Have you traveled them before? But at the moment, as I might say, that only a few people have some personal experience before traveling on autonomous vehicles. But if we ask the people, would you be ready to use autonomous vehicles for your everyday mobility in the future? And the graph is on the left, you can see 43% of the respondents, they answered yes, they are ready. And 40% they said, okay, maybe, perhaps, I'm not sure yet. And only 17% said, no, I don't like, or I will not probably use autonomous vehicles, whatever the situation will be. And the reasons were the people were thinking that they might use autonomous vehicles in the future were especially the following: to get an access to the transportation. 72% of the people said yes, it might be the case. On bad weather, 43%. For school transportation, 40%. For carrying heavy stuff, 35, and other reasons were representing only 7% of the answers. But I would say that even the public attitude seems to be rather positive when talking about the possible usage of the autonomous vehicles. They also had some threats, actually. And we asked, from my point of view, it's quite interesting reply here. Do you like to use autonomous vehicles? And then do you let your child travel on autonomous vehicles when it's equipped with a certain control systems? And there are differences rather interesting from my point of view. Already, as I said, that if the respondents say that 7% of the respondents, they say that, okay, I will never use it. So 11% says, I will not let my kid to use autonomous vehicles. And then we had 3 different options: only sensor-based autonomous vehicles, when there is a safety operator but remote, and when there is a safety operator in a bus. And you can see actually that, especially till now, the people are thinking, or their attitude is that it is probably more safe if there will be a safety operator in a bus, and especially I let my kid to the bus when there is somebody taking care of possible threats or accidents or whatever might happen, actually, if something takes place. We also had a question: what travel modes could be replaced by autonomous vehicles by your idea? And you see, it's a rather illustrative fact here that it is basically 2 motorized transport modes. It's public transportation as a bus, and it's car. A little bit taxi, which is also motorized transport, not so much about walking, tram, or cycling, and none of those 15% of the people. So basically, people say, yes, there is an option that autonomous vehicle could replace a little bit some travel modes, but basically we are talking about a car and bus transportation. Do you agree that autonomous vehicles should be a part of public transportation in the future? Yes. 73% of the persons answered yes, it might be or it should be a part of the future public transportation system. 90% they had no opinion, they don't know yet, and only 8% replied that no, autonomous vehicles are something different. It shouldn't be or it wouldn't be a part of the public transportation in the future. So I'm trying to make some short conclusions. Just as I said, there were much more questions, and we have a report. Unfortunately, at the moment it's in Estonian, but it's available basically about the rest of the questions. But trying to conclude here, I would say the following. The public attitudes towards autonomous vehicles use in the future at Raivo municipality are mainly very positive. And the residents see that the autonomous vehicles' role basically as a complement to the public transportation services, probably within mobility as a service context. However, there is still need to define the areas where autonomous vehicle services are more effective based on a certain objective characteristics. Just as I said, because of some practical limitations about the speed, about the time-saving ability, about the capability, there is quite a big need to define where autonomous vehicles might be using and getting some positive effect, in spite of the many municipalities at the moment are looking for autonomous vehicles to be used for some reasons, but it's not quite sure. And especially in order to answer the last question, we are already started some activities, which probably Anders and Serio can describe later a little bit more in details. That was for my point. Thank you very much for your attention. And if there is already at the moment some questions or replies, I would be very happy to reply. Thank you.
Yeah.
Thank you.
Yeah, we try to keep the discussions in the
okay.
lively discussion part in the end of the whole session, so you can save your question.
Please, as mentioned, please use the chat as your notepad as well, so to type in questions already that pop up to your mind. And currently there's nothing except the link that I posted a while ago. So let's move on.
Yeah, and then we have great collaboration team with Serio Agriesti and Udal from Serio from Aalto and Andres from TalTech side about behavioral models, synthetic population, and public database. Please take the screen.
Sure. Thank you so much. Okay, spoiler. I should go back to the first slide. So I'll take over from what Professor Hunter said. We are exploring as a joint collaboration how a behavioral model can be exploited to frame the future EV demand. By EV, I mean automated vehicles, obviously. This is framed in a wider, let's say, research project that aims to integrate two different models for the same city to frame both the demand related to automated vehicles and the supply, because automated vehicles may be used by more people and they may have a very disruptive effect on the road network, which in turn would affect the demand. If the congestion worsens a lot, no one will use automated vehicles, regardless of the comfort on board, regardless of the cost, of the distance, and so on. The first piece of this wider integration, which is what I will focus on today, is an agent-based model named C-Mobility that is able to frame, as I was saying, the result of the behavioral model, so the number of tours, the destination, the distance, the modal share, and so on. While on the right, there is the other part, which is Aimsun, which is going to be used for the supply side and to simulate a fleet of automated vehicles. An agent-based model requires a very large database. And this is where the developed database and the synthetic population part of the presentation becomes topical, because this data set does not exist for privacy concern. You need details about the income, the household structure, the workplaces, the education, and so on, up to the individual level. So the first thing we had to do was to develop this synthetic data set, which is open access, completely anonymized, so can be exploited also by other researchers. It includes 400,000 individuals and all the households. It was developed also in a joint with, thanks to the help of Professor Antov that shared a survey that we could upscale. It was 4,000 individuals and we upscaled it to 400,000. These are just some results to show that in the end, this phase was quite successful. You can see the share of the residents across Tallinn on top in the synthetic population dataset, and on the bottom left, you can see from the census what is the distribution. On the right, we can see that the match is almost perfect. The same can be said about income level, even though on the right from the synthetic dataset, we kept it qualitative to keep it anonymized. So it is very high income, medium income, and low income. But the distribution, again, has been framed somehow correctly. We focused also a lot on the workplaces and education anchor points, which are, again, not public at the individual level, but are very important for a behavioral model. Also in this case, we finished the activities and we got satisfactory distributions. On the right, you can see how the total per each district matches, and on the left, it is framed how the origins and distributions do match. If we take the example of the Lasnamäe district, we can see that most of the people residing there either work in said district or work in the central district of Kesklin. So it's what one could expect. This data set is pretty disaggregated. We are talking about a 500 times 500 meters grid, which also frames land use patterns other than just the totals. This is an example of the resident from Nome that work near the harbor. And we can see that in the more residential areas, we have a fewer concentration, while in the areas that are dedicated to the harbor or in the southern part, which is filled with business services and offices, the concentration is higher. So this is also the matrix that we validated against an existing study. The distribution, again, it was quite satisfactory, and I cannot stress enough that the synthetic population right now is public. So it's also pretty easy to exploit, because in the end, it's a very big CSV file with a legend and all the entries related. And it is on a GitHub folder. It has been described in a publication, so there is the whole process detailed if someone wants to exploit it. But now let's focus a little bit more on the joint work and how can we exploit behavioral models with a similar data set. As Professor Antov said, and I am collaborating with Andres on this, there are the results of a survey from the RI area. Also, there will be a trial there, so we will have also some feedback after actually the exploitation of automated vehicles, so it will be validated in the, let's say, with real data. So we will have this willingness to use the automated vehicles for various kinds of trips, for various distances, for various prices, and we will be able to see, again, how people would use these vehicles and to frame for which kind of trips these vehicles are actually the most useful. But this is for the RI area. So it is on a, let's say, smaller number of people. What is one of the research directions we could follow up then is to upscale this, let's say, propensity of the RI population towards automated vehicles to the whole Tallinn area, because with those results as they are, we can, through a regression model, probably we can frame what is the typical persona that would use an automated vehicle. Is it a worker? Is it a working age person? I mean, is it a retired person? Is it students? And so on. So that will be the first result. How from the RI area the connection is improved. But then we could upscale it with the synthetic population to also see what is the market base actually for automated vehicles, what is the business case that could be defined, and then upscale the results from the RI area to the whole Tallinn population. This will be useful, especially in defining the business case and the feasibility at a market level. As I was saying, the agent-based model that we're using is a behavioral model. It is based on nested logits, and so typical transport behavioral model. But what is possible to frame through it is the exact number of tours, the mode and destinations, and the time of the day. Those are the main steps for each individual, again, which is very, very detailed. And if we do this by upscaling the behavioral parameters that we get from the RI area to the wider area, we could be able to frame the total number of trips that Tallinn would actually generate with automated vehicles. This is one of the applications that is envisioned both with this collaboration, but yeah, focusing on the RI area. While if we shift again the focus on Tallinn, the building of this agent-based model and the building of a transport model in Aimson will allow us to carry out simulation that covers, let's say, all the sides of the transportation problem. This is something that cannot be done right now at the state of the art, and especially cannot be done with automated vehicles. It means that we will be able to carry out simulation that frame the overall demand in a realistic way, because the agent-based model is something that is already in literature, has already been validated, and can give very detailed results. But then we could validate this demand with the actual performance of the transport network. And the final results will be finally a fleet of automated vehicles that absorbs a defined demand, and then reproduces the supply performance in a way that the demand doesn't actually change. Is that so? You can actually build a case on that, because right now it's not possible, obviously, to have a trial at a city level because automated vehicles are prototypes, very limited in numbers, and there is a specific legislation and regulation and some boundaries. But at the simulation level, it will be possible to be achieved. Again, I'm showing some results from the two models. It is important to highlight the tour generations. That's what we will, with the results from the tour generation, one could actually forecast the earnings for a certain fleet. What are the revenues, the total revenues, because you have the total of number of tours, and you also have the modal share and the potential heavy demand that is absorbed. That will be based ideally on the RAE data. And since the RAE is so close to Tallinn, it is hard to imagine that there is a socio-demographical difference there that would make these results not as solid. This is just an example, not a very nice one, but it's the best way to show the detail. We have, for example, person number 4 that does just one trip through the day with, let's say, another motivation. There is a person 35 that goes to work and then comes back to home. We have the location, we have the mode, we have if the stop is the primary reason she or he left the house, the times of arrival and departure, and the trip chain through the day. Again, this is all modeled, so it's all anonymized, but it's also based on a behavioral model, so it's realistic. It has been calibrated against the overall number of trips generated in Tallinn and the recorded modal share. Other applications very quickly with what we have so far is that, for example, with the synthetic population database, it is possible to assess future scenario in a very detailed way, because again, it is very anonymized and it's very detailed. So it is possible, for example, to test different remote and hybrid working patterns, which is very, very actual right now. And it is possible to assess the future scenario with different trends, just to, let's say, understand the outcomes and their effect, not only on mobility, but I'm also thinking about the real estate markets, because you have different zones, different patterns, maybe tied to the income level, maybe tied to the gender age distributions, and so on. Accessibility studies are also possible in that sense. This could also be carried out with automated vehicles, meaning that, for example, in the RAE area, an accessibility study is very much in the things. We can carry it out because we have the output from the survey. We will model the typical personas that will benefit from the automated vehicles fleet. And there was another one. Well, obviously the synthetic data set is an alternative source of data for any kind of model building that could be there. But that was my presentation. I don't know if Andres wants to add something to what I mentioned, or otherwise the question we said to the end. Thank you so much for your attention.
Yeah, Andres, feel free to say something if you want.
I can say 2 things. What is very positive. I see that the presentation of Dago Antov is very informative, and he has lot of novelty for one scientific paper already now, Dago Antov. And Serio has also lot of information already in this stage for very good cooperation paper, second cooperation paper already. But we are working with Aalto Group and mostly with Serio and Dago Antov to make some kind of joint paper. And we are in the phase of agreeing the concepts of models, how our knowledge can be joined with the knowledge and ideas of Serio, and make some kind of mathematical model that combines hybrid model that combines the both concepts. So because we are in the very beginning stage, I would not like to confuse the situation in this very early stage, because we have already very good information from Dago and from Serio today, what is very, very well explained. So I will not present my ideas. It is on the base of bookkeeping, how we divide the trips from one zone of to districts of Tallinn. Must we divide the population to the groups? My opinion was that the number of groups of population must be minimized, and it can be minimized to 2 groups. In the morning rush hour, those who stay at home and those who move, either to schools or other to workplaces. Serio is trying to build such kind of model what has more groups of population. So I think both ideas can be somehow joined. So this is my small comment. In the end of our meeting, I will make maybe some more general comments.
All right. All right, good. Yeah, the Finnish Means project, that is the big framework around us, everybody in the project. The collaboration between Aalto and TalTech is the highest priority, I think, at the moment on the road to the international research and innovation.
Starting from just knowledge sharing and sharing of activities that are ongoing, but hopefully leading into actual collaboration and into new project initiatives that could be from start to finish done together. So this is what we hope to achieve.
The last one of the prepared presentations is Raivo Sell. The title is something like Technical and Legal Reality of Level 4 Autonomous Vehicles, Barriers and Concerns. So feel free to take the screen.
And thank you, Andres.
Yes.
But I don't have rights to share my screen.
Oh, just a moment.
I can draw on the board.
Raivo Sell.
Oh, Sell.
Yeah. Now.
Raivo West.
Yes,
Yeah,
Raivo.
Now you should be able to share. Perfect.
All right. So yes, the title we agreed was Technical Legal Reality of Level 4 Vehicles, Autonomous Vehicles, and I just put together some technical and other concerns which we need to deal with, and giving a short overview about those. Okay, so autonomous driving, yes, it's pretty hot topic, and where we get there, it's actually changed quite a lot over the time. I just had yesterday conference in autonomous vehicles in Florida, and the one presentation started with that in 1975, there was some attempts to have autonomous vehicles, and they estimated at the end of the 70s or beginning of the 80s, there is already autonomous vehicles on the road, which seems pretty funny at the moment. And even a couple of years ago, Elon Musk announced basically that by the end of the year 2020, there will be level 5 autonomous vehicles available, because there's no fundamental challenges remain. But as you know, there's still we don't have these vehicles on the road, and they have to postpone all these promises, and not only Elon Musk, but also other big companies like Ford, GM, and others several times had to postpone their promises in autonomous vehicles. And that's something we have promised or hope to have, but reality may be rather something like this, that yes, there are autonomous driving functions. They work pretty well in standard environment, but there are many challenges, especially those small things are not enabling us to have a full autonomous driving. Little bit background about the different levels of autonomous driving systems. So we have basically 6 levels defined by SAA, and level 4 is fully autonomous driving, but in limited operational design domain, which means that it's not available everywhere. It's available with limited conditions. And level 5, which is the fully autonomous driving in any conditions. So there is no that big functional difference, but rather difference where and what conditions this autonomous driving is available. And most of our current vehicles are level 1, level 2, and if you talk about personal cars. We don't have much level 3 vehicles, but we do have a level 4 vehicles. And that's exactly because this operational design domain enables us to limit all these conditions where this autonomous driving is engaged. And it can be limited in various different ways, starting from the graphical location. So we define the area like we had in our previous talks, RAI area or whatever. So we can pre-map or make this area very well known for the vehicle. There is a road types, speed, very important issue specifically for the level 4 vehicles, that we are driving in a low speed. We don't drive, let's say, in highway speeds. So it's pretty different conditions and functional setup for the vehicle, which depends on the speed. Also weather conditions, day or night, traffic conditions, network conditions, and so on. So it means that if we limit our operational design domain with a specific parameters, then we can actually have quite, let's say, simplified way to bring the vehicle on the road. But of course, its limits also its functionality. And this level 4 vehicles are mostly AV shuttles, last mile or first mile shuttles, what exist in these most common forms like Navi and EasyMile, most well known, but also our Aalto developed here in TalTech. Also in Finland, there is a Sensible 4 vehicle, which is one prototype. And there are many others are coming specifically from China, from US. The big OEM companies are paying attention to these shuttle buses. So this is a classical level 4 autonomous vehicle without steering wheel, without brake or acceleration pedal. So there is no driver seat, but there's still manual driving option, which can be switched from the autonomous to the fully manual driving in case of need. So the technical issues or barriers, what we have, first I would bring out the sensors. The autonomous driving is relying on the sensing, like human driving as well. And you need to have pretty good sensing capabilities in order to make proper decisions. And the most common sensors for the vehicles are radars, lidars, and cameras. Depending of the function of the vehicle, the sensor set can be also quite different. For example, the private cars like Tesla are relying mostly on the camera and radar. The L4 shuttles are relying mostly on the lidar and using cameras or GNSS for the corrections. But as you see in this table that every type of sensor have their strengths and weaknesses. For example, radars are good for the distance estimation, but they are not that good for the object classification. And also in the LiDAR are good for object detection, but not that good for tracking. And also they are not very good for high speeds in terms of frequency or speed of what they can handle the data collection. And they produce a very huge amount of data, which needs high processing performance. And the cameras are more similar to the human eyes, have a poor weather performance, but on the other hand, good lane tracking and so on. So the answer is here the sensor fusion, but it gives another challenge that we have to have very good machine learning algorithms. And that's another barrier or technological issue at the moment, that machine learning algorithms are not yet widely accepted as a safe solution, because mostly of high performance computing need for the sensor fusion at one point, but also the lacking of contextual understanding. For example, in the image left, you can see the vehicle, which is nicely classified. But if there is an images on this vehicle, which we can see quite a lot in our daily traffic, the machine learning algorithm are detecting these as a bicyclist or persons, even they are just the pictures. And if we make decisions based on this classification and thinking that we have a bunch of bicyclists in front of us, of course, the decision-making process is not correct. So this neural network training is definitely the issue. And also if we talk about other problems like direct sunlight, again, it's very, very hard to make good decisions. The technical issue about edge cases. So there can be good algorithms for the standard driving options. But as we know that unrare or rare situations or just can happen on the road, like animals jumping on the road, or there is some construction going on. So again, in the human perspective, the common sense reasoning helps us to solve these problems. But for the machine algorithms, it's not that easy. There is no training data, and we can't just train everything, all possible solutions. So it makes it difficult actually to make reasonable decisions in these edge cases. What about regulations? So that's also the barrier, of course. And it's not only that we have one lacking of autonomous driving law or something like this. First of all, the safety is the biggest concern, and there are different safety standards, but there is no direct safety standard for autonomous vehicles. There are many laws actually, or legal acts connected to the autonomous vehicles, like vehicle registration law, passenger transport law, also the vehicle operator requirements. For example, if you talk about teleoperation, then this teleoperator must have a proper category driving license. So if you talk about the passenger transport, then we can imagine that the teleoperator needs to have a proper category, but maybe these people who have this category are not that good of computer gaming. So which is teleoperation is more similar than just operating the full-scale vehicle. Also data protection laws, liability laws, and so on. So in one project, TalTech has completed this Sophia Baltic, has quite a good overview of legal situations a couple of years ago. So the area is actually coming very fast at the moment, specifically this year. It's in EU regulations currently going on about the type approval for the motor vehicles, regard of autonomous driving systems, and the initial scope is robot taxis and shuttles. Also in Germany, there is a traffic law changed already for the L4 autonomous driving, but there are implementing acts not yet approved. There's in France different things going on this year, and also in the Netherlands. And also in Estonia, sorry, this slide is in Estonian, but at the moment working group consisting of industrial partners, ministries. The transport department is actively working with Estonian legislation in order to make changes in traffic law and technical requirements for the automated driving systems. And there is two approaches. First is for the teleoperation technical requirements, and another is requirements for autonomous driving systems. So there is a working group going together in every month at the moment, and also universities are involved. So there is also social acceptance, of course, like Dago already explained what our local research resulted in. I was just wondering, it's very close to the US survey, which I have presented here. Also the 15% saying that they never use autonomous vehicle. They don't believe it's going to be in the market, and quite a big amount of people say that they would never use it. Also the people, majority of the people demanding 100% of safety before they would take a ride. So it's actually a very big barrier. We need to train people. We need to familiarize the technology during the pilots, what we are doing already, so that people start trusting. And it's not easy. I don't know how many have experience of driving the fully autonomous vehicle, but I can say that first time can be quite scary because you have no control whatsoever for making decisions, and you don't know where the vehicle is turning, specifically if it's public transport and you are not maybe that familiar of the specific road or every turn. Ethics again comes in, so it's not that simple anymore, and that's the very common question what journalists are mostly asking. Okay, what's the autonomous vehicle, how it decides, kill one or kill 10 of people if there is a this kind of decision needs to be made, or do you save the passenger or do you save the pedestrian? Do you save old or a young person, and so on? It's actually different in the cultures, like in Asia, Europe, and also in age groups. So it's actually very serious issue. It also comes to the privacy. Now we need to consider more and more, because these vehicles are going to be a connected vehicle, and of course tracking, location tracking, sensor data. Those vehicles are equipped cameras, lidars, which can be and they are storing videos, or stream videos when they're driving around. So all these kind of concerns are coming into place, and of course the cybersecurity issues. For example, our vehicle is connected to the traffic lights. Teleoperation is a very big concern. If someone can take over the autonomous vehicle remotely and make harm, or having bad things in mind, so it can be very dangerous. So it has to be dealt quite a lot. And yeah, for the conclusion, what we are working on, what's important also is the simulation and the validation. If you want to bring the vehicles on the road, we have to put much more attention to the simulations in the virtual environment before we go to the road. If you compare it with the standard cars, which needs mostly in technical validation and testing, but here we need to simulate and validate the autonomous driving decision-making process, which is much more complicated. It also brings the issue that if there is a software update, so how can we sure that the software update is improving the system, not maybe making some things worse that have happened. For example, in mobile phones, you know that maybe update will drain more battery than the old version, but this kind of safety critical issue can also be problems with the software that's will be anyway updated quite frequently in autonomous vehicles in the future. And there are different concerns, but I think my time is up. So yeah, here is just the topics what we are working in autonomous vehicles research group at TalTech, and of course doing in collaboration with Aalto. So thank you, and I give floor back to.
Thank you, Raivo.
Yeah.
And yeah, like we were saying, I mean, you kind of just scratched the surface of this really wide topic, covered quite a large area of including the ethics part, legislation, and then technical aspects. So I think we could have a quite in-depth discussion for an hour on just this one. But let's try to cover all the presentations and move on to the discussion.
Yeah. Well, the one sort of background question for this session, or the actually motivation for this session, is to see are there any possibilities for robotics people and transport system people to collaborate. And I've understood that there are options, and then Dago is, on a daily basis doing that. So we are happy with that, but of course that needs more people. But in sort of that very general level, we can say that the goal of this session is nicely fulfilled in that sense. One thing in my mind is this the sort of definition of autonomous or automated vehicle. The naming seems to be very well, depending on the speaker. Even in this session, we have heard about automated vehicles or autonomous vehicles, and almost the same, but perhaps not precisely the same. But simply thinking of this survey having more than 800 answers in Estonian side, or Tallinn and Rai area, if I was correct. What was the definition of automated or autonomous vehicle there? I mean, Dago, you said that people have no personal experience typically about autonomous vehicles, but how was it sort of referred as public transport, as a sort of bus, or these existing sort of campus vehicles, or was it referred more like private car in your own use? Or
maybe we can share this question between Dago and Raivo. So how do you define the autonomous vehicle when you are doing surveys? Because again, people are not familiar with the concept, and it could be misleading just because of the terminology.
Yeah, maybe from technical point of view, the common people doesn't make any difference. Are we talking about autonomous, automated vehicle, self-driving vehicle? So it's all the same for them. And in Estonia, we also have a confusion with it's called isejuhtiv, iseliikuv, which is also misused quite often. So it's but just the common people, it's all the same, I would say. But of course, by the definition, we currently talk more with an automated vehicle, because autonomous vehicles means that it has kind of higher level self-confident or AI applied, that it's more like doing its own decisions. For example, if automated vehicle, if you say that let's drive the work, automated vehicle will drive the work. But in worst case, if you say to autonomous vehicles, drive me work, autonomous vehicles can say, no, I think it's better to go to the seaside, and drives you there. So yeah. But I think the common people, if you do this kind of service, no difference. Rather, I think the question is
good example.
Public transport or private car.
Okay.
Maybe I can add a little just to Raivo. Yes, I agree totally. But in Estonian, I think in Estonian language, it's a little bit easier because we don't share actually these different technical terms very much. We use just the is a juhtiv or self-driving vehicle, and especially when we made this questionnaire, we just were focusing on those terms actually. But what was not actually in my presentation, but what Raivo was mentioning, I would say that due to this questionnaire results, we get a result where 9% of the people have been driving in kind of the AV, and 5% only have never heard anything. So we didn't actually separate different types or terms in this meaning, but just putting there also in the question that was a kind of a picture, because especially the one which has been driven in Estonia and especially in Tallinn has been a little bit more familiar to the people we asked. So at the moment we don't separate these terms in our questionnaire, but basically, yes, I agree with Raivo, of course.
Yeah, I'm just thinking the common people, they have practical issues in their mobility, and if we are thinking of public transport, or if they're thinking private car, I think it's totally different story for them, and these American results that I will never use AV. To me, it sounds like they are never going to use public transport or something like that. I mean, in a way, they're talking about different thing.
And again, their images might be based on, for example, I mean, there's a big difference whether you're having a private autonomous vehicle for yourself, which is a taxi without a driver, or if we're talking about mass transportation, which is a minibus where you share the ride with 6 other people. And again, this context might be affecting the impression and also the answer. So these were just the things that came to my mind. But have you more specifically defined by my understanding, but you have just called them autonomous vehicles and not specified it?
Yes, exactly. I think that basically the people are taking these autonomous vehicle or automated vehicles, just a vehicle which drives and there is no steering wheel and a driver in the car. It might be even kind of the operator sitting there, but he is not really doing the steering. And that is a general understanding about this.
Yeah. And I think we all in this session, I think we all are, well, before and after Corona time, we are frequent flyers, and probably we have all used automated vehicles when we are changing terminal in international airports.
But especially in the air as well, because I think that most of the time the airplane is flying without any kind of steering, basically.
Yes.
But people don't know it actually.
Yeah. I've understood that since 1980s, it was the aircraft were operating quite sort of in a way automated, but the big audience probably cannot stand.
Definitely a matter of experience, though. If they have a chance to try it out, if the first experience is positive, I'm 100% sure that it changes drastically the trust. The question is about trust, and of course there are people who trust the technology in general. They want to try everything new, but there are also a certain amount of people who just against everything. Is it the corona or war in Ukraine or new technology? Always against. So that we don't break. But I think most people think about, or they just don't have any experience, and then they have an opinion based on some public newsletters that they have read, and it just depends what they have read previously. Was it positive or negative aspects?
I agree.
Only that the self-driving vehicle had an accident years ago, which had a very high publicity, and they haven't heard anything else, then of course they say that they are really unsafe and they never want to see them.
Yeah, absolutely. I agree here very much with Raivo, and want to just highlight 2 things. The first is that this first question that we did last year is just one of the series, because if there will be introduced a real autonomous vehicles on RIS, so idea is just to repeat the similar question and see how the people's attitudes are changing after they have been even using or seeing the autonomous vehicles on the streets. That's first. And the second, maybe not so many people have actually driven, been inside of autonomous vehicles here in Tallinn, but they have seen a lot of these small delivery robots on the streets, and they are very lovely, and we all actually like them. So I think that the most of the people can have some kind of experience about these robotic vehicles, but very often we don't just put them into the same scale or into the same hole. There might be different attitudes and understandings about what the AV really is, of course.
Yeah. So we have in chat several questions. Have you, Matti, moderated?
Yeah, I'm going to be replying. There's now some discussion getting started in the chat. So first of all, a request to Raivo for sharing the study regarding the people wanting to save passengers over pedestrians, or the ethics study, if it's available. So, or if you have a link, then you can share it in the chat. And maybe
public survey, and or that's actually the article, so I can find it out very soon.
And maybe we can post it in the web page on this 12th Research and Innovation Seminar aside, so that people will find it afterwards as well. Then a couple of more detailed questions. So from Dimitri, do we have any knowledge or understanding in operational requirements for AV for lighting environment after dark? So are there requirements related to dark, operating in the dark?
Yeah, if it's a question about operating in the dark, it's actually depending the sensors at what the vehicle have. And if you rely on the LiDAR and radar, then this visibility doesn't really matter. We can drive without lights easily. But if it relies on the cameras and there is, let's say, no infrared or something which lights up, then of course this machine learning is not working well. So if that's the question, I'm not sure. But in terms of sensor capabilities, they are much more capable than human eyes, of course. That's for sure. Question is how well we are able to leverage this sensor fusion and then make a kind of reasonable decision based on that.
Please, Dmitry, go ahead.
Right. Yeah. Thank you very much for your answer. So yes, actually, the question was like just to think about possible intersection in research work. I have a background in the lighting design and lighting research in the urban environment, and I just thought, so now, for example, the lighting should somehow serve like the people needs, the environment needs, like talking about the lighting perspectives. Should it be like, should it somehow in the future also serve the robots needs? Like, I mean, the machine vision and all that stuff. So do we need any requirements for example, you had the Raivo, you had that kind of a table where you had these limitations, and one of the limitations was like the day-night limitation. So actually there was, if I understood it correctly, so it was like, so the autonomous vehicle will work well in the daytime, and in the evening they will work like with the artificial lighting, and will not work without the, for example, in some rural areas. So I just asking about these limits or steps in the lighting quality. For example, if we have artificial lighting in the city, so it can be like on different levels, we have different lighting sources. For example, we can have LEDs, which like provides better lighting, or we can have these sodium lamps, which provides like another lighting quality, or we can have different steps between the luminaries, and we will have different uniformity. Will it somehow affect the work of the autonomous vehicle? Like, for example,
I understand there is actually 2 points maybe in this question. One is that how this different lights affect. Another is, do we need a specific infrastructure for the autonomous vehicles, like in road infrastructure, as I think. So the answer would be that actually we don't need, the lights don't affect that much autonomous vehicles than they affect the human drivers. So human drivers performing much worse in poor lighting condition than the autonomous vehicles, because this sensor combination, and specifically if we talk about this L4 low-speed vehicles, they rely on the LiDAR it's the laser invisible light, and we can drive in full dark without any problem. And for our vehicle, it was actually the issue that we didn't have main lights initially, but it's required by the technical requirements, official technical requirements. So we had to put the lights just for other vehicles or operate on the road, not that we need it for the driving purposes. And of course, if you need the object classification, which is mostly based on, or at least help of the camera, it's usually going with a LiDAR camera fusion, then the lights is necessary, but the cameras are performing better than human eyes. And we can have different filters to filter out different conditions. We can have a very good infrared beamers. So basically we can have like even normal, the newer cars with a driving assistance system. For example, Mercedes, you can switch that your dashboard actually shows infrared camera view, and you can also drive without headlights, basically as a human driver, because you have full visibility or night vision systems. So it doesn't affect in that sense. And what concerns to the infrastructure changes, if the vehicle relies heavily on road markings, which is case of Tesla and private cars, then it must be rather good conditions. And there will be issues if there is snowing, for example, the road is covered, there is no lane markings visible, then this vehicle is in the trouble. Again, this L4 low-speed vehicles, they are relying maps, point cloud maps, which is compared with the LiDAR real-time data, and don't care that much about line markings. So we can drive even without seeing any road, because we are localizing a vehicle based on object around us. So this vehicle can handle well in urban environment, but if it goes to the desert, then it's lost, because there is no reference objects around that. So it depends very much of this, again, this operational design domain, where you design your vehicle to operate. And that's exactly the reason why we don't have L5 vehicles, and we're not going to have them in the close future, because it's very difficult to make them work in every different condition. It's easy to design, relatively easy to design to work, let's say, in our university campus or in this RAI area, or what we are working like Tallinn Harbor area. We can have a very detailed map. We can build a vector map having all line markings, everything, all the signs, and then it's good to operate. But the same vehicle with the same sensor set and algorithm must go then in different city, let's say in Lapland, in the forest, then it doesn't work anymore. I have to have totally different training data, sensor set maybe, algorithms maybe, and the speed comes in, the weather condition comes in. So that's the question. But I believe we shouldn't have create a new specific infrastructure for the autonomous driving, because the human driving vehicles and automated driving vehicles must work together at least next 20 days, 20 years.
Maybe expanding a bit on this, something that you already started covering, but this is kind of the vehicle perspective on how the vehicle behaves. But then stemming from my own experience, for example, in China, where the electric scooters became super common already more than 10 years ago. And this caused a sudden change in the system, because the electric scooters are silent, and usually the people were saving their lights, so they didn't have the headlight on, which meant that you had these vehicles silently coming for all directions, and it affected how the pedestrians were again feeling safe in the environment. So if you take a kind of pedestrian perspective into this, should then the light vehicles be exteriorly illuminated in such a way that people would see them, especially again, electrical vehicles might be more and more silent, so that again they interact with pedestrians and other ecosystem more effectively.
Exactly, that's again the very rising topic of research. And we have done experiments, and maybe you noticed in one of my slides, we had this green triangles on illuminated, basically that we are detecting that if we see the person on the pedestrian crossing, and if this empty vehicles is approaching, people actually are quite scared that because they don't have any confidence this is the vehicle really understanding that I'm there or not. Because if you have the human driver, you have eye contact and you say, okay, that I'm noticed, even it's not yet braked fully down, I can easily cross the road.
Yeah, the driver can just show that, yeah, go ahead.
Yeah,
But the autonomous vehicle doesn't have the hand to say that, yeah, go ahead.
If you have eye contact, you understand from the driver perspective that yes, he noticed you. It's not on this phone, and he will brake or she will brake. But that's the case, and yes, we have done different experiments with the visual kind of marks and signs, also audio warnings, and it's also what I see that there is a problems coming in is that if you cross the road in the wrong place, so if those vehicles, and they must have very let's say delicate, and they are not gonna hit the pedestrian if they cross the wrong place, but if they are these vehicles are too polite, then we can't operate them because people get used to it. Okay, I can cross wherever I want, they never kill me. And if you want to operate this kind of a fully following traffic law vehicle, let's say in Vietnam, in Hanoi or somewhere, you can't just operate. So it's a really difficult question because you have to violate this traffic law, or people are violating, but in some kind of social agreement level, which is really hard to achieve for the autonomous vehicles and how we deal with this issue. So that's the very, very important question, and there is no good solutions. So, and
Thanks.
of course, then the silent case as well, that how we notice that the car is coming and all these aspects.
Thanks. And so that this doesn't come just interrogation of Raivo, then do other speakers have anything to add to this?
I can give a small comment actually here, because I basically agree what Raivo was mentioning, because I think this kind of understanding how the autonomous vehicles will act in a real traffic is quite complex question here. You know, we have such kind of regular experience with these small delivery robots with a height of maybe 1 meter, and especially here in Mustamäe area, they are quite common. People are already knowing, but then we face the kind of interesting problem with them when they try to cross the pedestrian crossings on the streets, because people first, especially the drivers, trying to be very polite and give away because there is somebody on the zebra. And then later on, they find out, okay, it doesn't work like they said. Now, kind of the attitudes of the drivers are very different. Some are trying still to give way to these small robots because they are very, very nice, very, very kind, very lovely. But some are urging, okay, this is just kind of an automatic thing, and then we can just drive through. Because I think basically, if talking about AVs, one of the main goals is just to improve the safety. But especially with such, how to say, backups might cause a problem which really are needed to be solved in the near future, because I don't think that we even face all of them at the moment.
Thanks.
I think that automated vehicles must have in standard such kind of tracking of people by light or signals. This must be standard of automated vehicles. If people are standing somehow or not noticing those, there must be light and voice signals like a standard. Warnings, warning marks, both light and noise and voice.
Well, yeah, maybe we need to come up with a new color for light that is dedicated for autonomous vehicles, so that it's not the police cars and ambulances and maintenance cars, which already kind of have red and blue and yellow lights. So maybe there should be something else like a green light that's indicating that the vehicle is autonomously operated.
Actually, we did this, and what this resulted was that transport department said that you can't have these kind of lights. They're not approved by EU. So
Yeah, I remember having that problem with the third braking light in the back as well, that people got fined for having better lights, but maybe this is something that can be changed if it's a regulation or legislative issue.
Yeah. In Finland, yeah, in 1980s, that was the first reaction of public authorities, that it's denied, and now we have in every.
It's mandatory, yeah.
Yeah. So are there
Very good issue.
chat there all kinds of activity and links delivered and so on. So this is very interesting. I mean, the AV. I mean, the AV is good. It's autonomous or automated or so. AVs are, you know, and the philosophy behind them is that they should be able to recognize everything and everybody, all the pedestrians and whatever is the mode of transportation and all that, and the history of hundreds of years is that it's a mutual sort of understanding, the eye contact, as Raivo noted, as the main thing, but other things also, interpretations of the little moves from every party. Yeah, hopefully we are not getting new red flag act as we had in mid-19th century. You know, that there were person with a flag, you know, obligatory to walk in front of car to warn everybody that the vehicle is approaching. Of course, that was a sort of transport policy. I mean, train in UK, in the train operators were strong enough to initiate this kind of law, but it was in action some years actually. So as an example,
there's a question regarding training of the algorithm. I think this is also a rather good and general one. So are there any data principles when it comes to training of the algorithm to recognize different types of people? So, for example, people who are in wheelchair or children compared to adults, dark skin complexity versus lighter skin complexity. I heard about issues, for example, in VTT in Finland, where dark-skinned people could not use the fountains in the toilets because the fountains were trained to recognize white skin, and anything that was darker didn't operate the fountain. So how are the algorithms trained, and is this being considered so that it doesn't come as a surprise, for example, if a person in a wheelchair or different skin complexity or with a mask appears? I know it's an easy one.
Yeah, I think this training, algorithm training is actually very kind of not that straightforward, because we just can't train for every situation or all possible solutions. And also one have mentioned later that we should move more to the system view, which is fully correct, that we just have to raise the like general reasoning and context understanding of AI, which is still a challenge, like humans are behaving, because it's just impossible to train, just purely follow the data set and then be successful in autonomous driving. So yes, currently this is how it works, and there are many training sets available, also open source or freely, like from the Waymo and Kitty, which is very much used for training. But it depends also a lot of this particular environment where the vehicle is coming to operate. And even we have the experience here that in the same location, geographical location, in the small area, you may have to update your training data depending on the season. For example, we had this Navia bus a couple of years operating Kadrioru Park. It was the area was mapped in the summertime, but when it comes to autumn, leaves falling down, then this data didn't work anymore. That the vehicle lost its localization, not mentioning that the object classification is different. So that's not that easy actually to handle. And yeah, we can have even like human detection. There can be so many different aspects, like really wearing the masks or whatever. So and you always get some probability. I think a human driver that sees someone on the street, it can be say almost 100% sure that that's a human, whatever mask or skin color or wheelchair or whatever it has. But if it's just this artificial object detection, then it gets probability like 75%, 95%, or maybe 50%, and then 50% it can be a stone or something. So it's if it's approached like this, then we never reach anyway the human level driving capabilities. So yeah, it must be transferred to more context understanding and more higher level classification and decision making process, but that's not easy yet.
Yeah. Well, you may have there's some chat thing. I'd like to raise totally different perspective now. I see we have in this session, we have Paolo Pino from Aalto and Dimitri from Lighting or Illumination Group. And I've understood that in this last mile AV planning, 3D modeling and sort of digital twin in a way is very important tool, or actually sort of environment where people are working. So do you lighting guys, do you have any, are you willing to contribute this 3D modeling of AVs to have an interest in that direction? Because I mean, you know, day, night, and artificial lighting and all that. So making it more realistic. I'm not professional here at all, but just trying eagerly to create some kinds of collaboration between Aalto and TalTech and between different disciplines.
Or conflicts. I also like conflict if there's a big fight between.
Yeah. You don't need to be polite.
Right, that's a good question. Actually, that's why I asked my previous one. So my question here is, what is the functions? Like, what is the reason of this lighting? Should it be just like the model of the lighting pole, or like what for? Like, what is the need of putting light or like luminaries in this model? Like, so do we need just a model of the light itself, or we need like lighting characteristics, or like how much light will we have, or what is the spectrum of this lighting? So all of this data is actually depends on the reason. What is the like what for we need the light in there?
Yeah, I haven't specifically actually considered that the lighting can be an issue for the autonomous driving, but it can be the case that if we have this data available, so it can be maybe correct the camera settings, for example, and then maybe change it dynamically in the way that if we move from one area to another where the lighting conditions are changing, I don't know, change the filter or change a little bit the algorithm, how this different corrections is applied, flickering or whatever. That can be the case, but it's more like tuning to the sensor readings or something like this. So it's not in principle applying in operation in general level.
Can there be cases where the exterior lighting is negatively interfering with the sensory system? Or is this completely just
problematic issues are direct sunlight if it hits the camera, and or a low sun on reflections. Reflections can be issues. For example, we call them cost objects, so that actually the machine algorithm can consider as a let's say stone on the road and applies the heavy braking, but it's a shadow in real life, and that sometimes is case. So it's like kind of all the false positives detections.
But then that would be mostly about the natural light rather than artificial light.
Yeah, most cases, yeah, because it's the natural light very strong and it can create the status. Maybe I don't know that if you're working also with this 3D models of the city, so that's something we are building the virtual environment and digital twin where we do the simulations of the vehicle. So that can be maybe. So I don't know how much you work on this, but that's what we are interested in, and we are heavily working. So before you bring your vehicle on this area, you have to fully simulate in the virtual environment where let's say the vehicle is as close as possible to a real vehicle. The algorithm is the same, exactly what drives the real vehicle, and the environment is also as close as possible to a real scenario. So if you talk with the RAI and Tallinn Harbor, we right now mapping it. First we do the maps, point cloud maps with the LiDAR, and then also we have drone maps from image-based maps, which we transfer to the gaming engine. So we previously had a Unity. Now, just months ago, we switched to the Unreal Engine-based maps and Carla simulation tools. So if you're working something like this, I think that would be definitely our interest of collaboration, because we have the methods how to make a model out of the drone images and also classify the objects there like buildings, vegetation, cars, and all this filtering and automated process development, how to make a good digital environment where we can drive our vehicle in simulated environment.
Nice. Thanks.
Good. Yeah.
So also some works, maybe if there is some kind of collaboration ideas based on that, and other groups can do the same, then we can move forward with this issue.
Yeah, speaking out loud, a couple of notes from the chat. There's a few links there to interesting articles. So anyone in the audience, I think we will try to share these links on the web page, but feel free to click them yourselves now. And I think it will be possible if you click at the 3 dots at the bottom, you can save the chat as well for yourself. So we'll create that text or CSV file, and that way you can store these links in the chat for yourselves as well. So thank you for everyone who has been sharing the links, especially for Anne, who has been sharing our Finest Center's Twitter, Facebook, LinkedIn, and YouTube.
Sitting here in this studio and controlling us that we, behave ourselves. One thing in the early stage of this or this session, the Serio's presentation and the, well, you mentioned, and in your slide you had social justice mentioned, and as a sociologist of traffic, I'd like to ask how do you handle the social justice sort of aspect in your work?
Yeah, that's a topic that I like, but I cannot dedicate to it as many energies as I want. The thing is that we frame a parallel Tallinn with our work, which is composed by parallel individuals that are not real one, but they have the same features, statistically speaking. So, for example, let's take one that is very easy to talk about, which is income. We have their distribution across the city at 500 times 500 meters. And by adding a new mode, let's say automated vehicles, public transport based or private lights, whatever, with a certain cost and with certain connections, we can see who benefits from them. Let's see that these vehicles worsen the congestion of private in the road network for private vehicles, because they drive slow, as we were saying, because they have to be more careful and so on. Who has to rely on the private vehicles because maybe they don't live in the city center or they don't live in the major centers scattered across the cities? Who is going to pay? So that's a first consideration, which is very easy to make. For example, if the service then costs too much, we are just providing an alternative public transport service for people that can afford it while relying the others to the car. In the dataset that we have, we didn't add some features such as being a foreigner, being an immigrant, having origins tied to the surrounding states and so on. But that's a thing that could be done if that's the focus, let's say, of parallel research. And then one could draw some consideration about where are the neighbors with the major concentration, how are they served by the new mode? Is there any disruption that penalizes them more than the others? And these are scenarios right now because we don't have automated vehicles. That's the good thing about modeling. You model it before so that you can avoid it. And that's how I will say you can address these kind of issues with what we have at hand so far.
Off topic, but well, I mean, social assessments are obligatory in many countries. When you plan transport infrastructure or changes in them. So this might be a very good tool, of course, needing this modeling done in advance. But when it's done, it's much easier, more accurate tool. Yeah.
And I see that Raivo added another link regarding the ethics issues of self-driving cars. So a study saying that people prefer the cars valuing passenger safety over pedestrians by this study. And definitely
article, it's not very new, it's rather old, but the ethics remains the same. There was a question earlier, but if you follow the end of this paper or article, you will find actually linked to this moral machine where you can try out what's your attitude in that question. There are different scenarios and you can do the judging process. So it might be interesting to see that how you feel about these issues.
Yeah, involvement technology. They were in chat, there were questions about that, and Raivo in a way answered to that.
And then also a couple of proposals from Andres regarding how to collaborate in the future. So first one related to smart cross-section or intersections project in Espoo. It should be joined with TalTech's Aalto project somehow. And the other one proposing a face-to-face meeting, for example, Baltic Electronics 22 conference special session. So preparing an article for this. There's a special call for papers with a deadline end of June. So this might be something. Andres, do you want to say something about that? I think these sound good as proposals.
I can say that in previous big meetings of all these FINAS project meetings, there was discussed how to intensify cooperation, and my idea was to use those conferences, what anyway happen in our universities, to make the special sessions where our people meet, present some kind of small conference papers, maybe preliminary work, and discuss all problems face to face. At least now I know one conference was what was declared yesterday. I think that it will happen in the beginning of October, but the deadline of papers, I think it's IEEE format, 4 pages, double column, will have need papers. Deadline is end of June. Just then maybe we can present our preliminary works there, discuss, and get also some kind of conference papers in IEEE Explorer database. So it already starts happening some real cooperation in the level of joint papers. Okay, this is my idea. maybe we have some other conferences. I think Raivo had something organized, or some other department, where universities have some kind of conferences coming before the end of year. It would be good. Okay. This is
maybe it's worth to mention that what Dago offered, this one transport conference, where I'm at least thinking about having paper about our mobility as a service X-Road platform concept over there. But Dago, I think it was also in October, so that would be probably a good way to go.
Yes, I think though it was quite, I think focusing just on the right topic actually, but I don't have this information right now here, but we can share it, of course.
It was ICOMASK 2000.
Yes, yes.
So I can paste maybe this information here as well. So that seems to be quite interesting.
And for any of this preparatory discussion, we don't want to be third wheels in any of the discussion. We will not be able to contribute much. Kalle will be able to bring some perspective into transportation issues. But if by any means we can assist in providing spaces, facilities, or video communication, for example, then please let us know if you have topics, or if you have an idea of a theme that could be presented in these research and innovation seminars. Then that would be our pleasure to help in organizing and arranging those.
Yeah, definitely. Yeah. So are there we have nicely big audience today, and a lot of things were noted in chat. Are anyone willing to raise the chat notion that was not noted by us, or anything else dealing with this enticing subject? Or are we approaching the end of this session? So as noted in presentations, the AV is very hot topic in publicity, and car industry is sort of supporting it. Quite traditional industry being able to say, show some initiative and sort of new things coming, but in reality, as we have heard also today, the real cases of AVs are quite restricted, and the sort of physical surroundings are pretty. They need to be very controlled. So this sort of American dream that you just sit in your car, or having citywide automated taxi system, it sounds very distant. Also based on our discussions today.
But it's good to have science fiction.
Yeah, science fiction is very important. I mean, yes,
what the future will look like, and really we have seen a lot of major changes with shared rides, Uber, Bolt, and so on, just within a few years, and they have really revolutionized the way we think about, for example, taxis, and we know what changes will come. When they come, that's something for Raivo to decide.
And well, I think where it is happening it's in logistics and warehouses, and there are robots moving things inside of the logistics centers and all that, and we don't know much about that. I mean, the big audience, so perhaps the biggest things are happening there at the moment while we speak. But it looks like we are approaching the final end of this session. Matti, you're very good in closing things, so could you close this session also?
Thank you for all the participants. I hope we can keep this discussion going on. Let's schedule a face-to-face or online meeting on the topic, preparing for joint papers maybe, and for joint project proposals as well. And with that note, before getting carried away, see you next time at Research and Innovation Seminar number 13.
Yeah, dealing with important things. We'll follow the advertising campaign we are spreading out.
Thank you.
All right.
And bye-bye.
That was very
Thank
good.
you.